Chapter 8.1, Day 1, Graphing y equals ax square, where a is greater than 1. Ax square is a quadratic function because it's a second degree equation, so this is called quadratic. A quadratic function is a non-linear function. Linear function, when you graph, it gives you a line as a graph. And quadratic function is a curve that is called a U-shaped graph. So it's a non-linear function that can be written in standard form like y equals ax squared plus bx plus c. Where a is not equal to 0, the U-shaped graph of a quadratic function is called a parabola. P-A-R-A-B-O-L-A, parabola. Now we are going to discuss the characteristics of a quadratic function. The most basic quadratic function is y equals x squared. This is also called parent function, where you do not have any number in the front or in the back. And that pure function is called a parent function. The lowest or highest point on a parabola is called vertex. The vertical line that divides the parabola into two symmetric parts is the axis of symmetry. Axis is also means a line. So a parabola for this type of a graph, is going to start from 0, 0, and it's going to give you a U-shaped graph. Now this point on the bottom, on the very bottom where the parabola starts, is called vertex. The line, this line, is dividing the parabola into two equal parts. So this is symmetrical part with this part. So two symmetric parts. And this line is also called axis of symmetry. So this line that divides the parabola into two equal parts is called axis of symmetry, and this is vertex. In this case, our vertex is going to be 0, 0, because the parent quadratic function vertex always lies at 0, 0. So if you have a parent function, it's going to start from 0, 0. Now we are going to talk about the domain. Domain are the x values. So the x values are going to be negative infinity to positive infinity. And the range is going to be 0 to infinity. Domain means x value and range means y value. Now we are going to see how they are negative infinity to positive infinity for x values. This arrow means that it's going to go to the left and up forever. And in this quadrant, this arrow means that this is for x value. For x value is approaching to negative infinity because x is negative in this quadrant. And it's going up and up and up. So y is positive infinity. Wherein in this corner, x is positive. So it is approaching to positive infinity for x, and y is also positive because it's going up and up and up. So y is also positive. Now for the x values, you're going to get negative infinity to positive infinity as a domain. For range means you're going to find out what is the y value and where it starts from and where it goes. So the y value start from 0 and it goes all the way to infinity. So the range is 0 to infinity. So the height of the graph start from 0 and goes up and up and up, which means positive infinity. Axis of symmetry is at x equals 0. So this is the y-axis line, and y-axis line is always x equals 0 line. So axis of symmetry is always a vertical line, and that is always x equals to x coordinate of the vertex. So axis of symmetry is at x equals 0. It is also x value of the vertex. When x is less than 0, the function decreases. When x is greater than 0, the function increases. So when x is less than 0, which means this part right here, the function decreases. When x is greater than 0, it increases. So now we are going to do example number 1, identifying characteristics of a quadratic function a greater than 1. Using the graph, you can identify the vertex, axis of symmetry, and the behavior of the graph as shown. The graph is shown here, and we are going to first find out the vertex of the graph. The vertex of the graph is the point where the parabola starts, and that is going to be this point. So the point is going to be here is 2 comma negative 3, where the parabola is starting, and that is 2 comma negative 3. Now we are going to make a line in the center of the vertex, and this line is called an axis of symmetry. An axis of symmetry is the x equals to x value of the vertex. So x value is 2, x value of the vertex. So our axis of symmetry is x equals 2. Now we are going to talk about the domain and range. Domain means the x values and range means y values. When you talk about domain, you need to know where the graph is going from left to right. In this case, this arrow means this is going left and up. So left means that x is negative infinity. Up means that y is approaching to infinity. This arrow means that is infinity comma infinity, because on the first quadrant x is approaching to positive infinity and y is also approaching to positive infinity. Now when we talk about the domain, we are going to talk about the x values, which is negative infinity to positive infinity. Negative infinity to positive infinity, graph is covering all the left values, all the right values for x. For range, we are talking about the height of the graph. So height of the graph means that what values the graph is covering height wise. So it start, you can see that it start from negative 3 and it's going to infinity. So the range is from negative 3 to all the way infinity. So the range is negative 3 to infinity. Now we are going to talk about the function when it decrease or when it increase. So you can see that here is the x value, that is 2. Before 2, the function is decreases. It means the function decreases when x is less than 2. When x is less than 2, function is decreases. When x is greater than 2 or greater than equal to 2, the function increases. We are going to do, you try problem number 1 and 2. And for number 1, you have a vertex that is 2 comma 1. So 2 comma 1. Axis of symmetry is going to be, when you make a line in the center here, axis of symmetry is the x value of the vertex. So this is the vertex, and that's 2. Domain, you're going to go from negative infinity to positive infinity. So from this negative infinity to positive infinity. That's your domain. Range is the height of the graph. So starting from y value 1 is going to go up and up and up. So starting from 1 is going to go to infinity. So for the function, when it decreases, the x value is less than 2. So this part is decreases starting from infinity to all the way up to 2. So when x is less than 2 means this side the function decreases when x is less than 2. When x is greater than 2 means this side the function start to increase. So when x is greater than or equal to 2, function increases. For number 2, the vertex, I found this point as -1 comma -4, so that's the vertex. For the axis of symmetry, this line x equals -1. For domain, it's going to go from left to right all the x values, so from -infinity to infinity. For range, the height of the graph is starting from -4 and is going to go up and up and up. So -4 to infinity. This is our turning point, x equals -1. Before x equals to -1 or when x is less than -1, function decreases. When x become greater than -1, which is this side, the function start to increase. So when x is greater than or equal to -1, function increases. Now we're going to do example number 2, graphing ax squared when a is greater than 0. Now, unlike previous examples, the graph is not given to us. We have to find the graph by plugging the values for x into y and graphing the coordinate into the graph paper. So now we're going to find out y equals 2x squared. So I'm going to use the table value that is given to me. I'm going to use this -2 and plug it in here to find the y value. So y equals 2 times -2 square, and that's going to be 2 times 4 because -2 squared is +4, and that's going to be equals 8. So the point is going to be -2 comma 8. Now we are going to find out when we plug it in for x value that is -1. So 2 times -1 square. Anytime you square the negative term, it's going to be a positive. So that's going to be 2 times 1, that is 2. Next, we are going to plug it in the value 0. So 2 times 0 square. So that is 2 times 0 and 0. Next, we are going to plug it in y equals 2 times 1 square. 2 times 1 is 2. And the last one is when you put the value 2 for x, so you're going to get 2 times 4, and that's going to be 8. Now when you plug it in or plot these values, the first point you're going to have is -2 comma 8. So that's going to be -2, 1, 2, 3, 4, 5, 6, 7, 8. This point on the top here, -2 comma 8. -1 comma 2. 0 comma 0. So this point is 0 comma 0. 1 comma 2. So next point is 1 comma 2, and that's this point right here, and 2 comma 8. Now we're going to make a smooth graph out of these points. So join these points and get a smooth graph. So the plotting points were -2 comma 8, which is this one, -1 comma 2, 0 comma 0, 1 comma 2, 1 comma 2, and then 2 comma 8. And then you get a graph that is this graph right here. Now we are going to make a graph for y equals x squared and then compare these two graphs. So y equals x squared is starting from 0, 0. So the first point for that is going to be 1, 1. And the next one is 2, 4. So 2, 4. And make a smooth graph. And you're going to get here is a red graph, and that is the parent graph. What do you notice? What I notice here is that both of them has a starting point same, or the vertex is same. For the blue graph, the first point is 1, 2. And for the red graph, this is going to be 1, 1. For the blue graph, the next point is 2, 2, 8. And for the red one, the next point is 2, 4. You can compare these points. See that for red graph is 1, 1. For blue one, the y coordinate is raised by 2. 2, 4 is raised by 2, 8. So the y coordinate is multiplied by 2. So it is vertically stretched graph. So the blue graph is vertically stretched graph. The red graph is a regular U-shaped graph, and then the blue graph is skinnier and taller, and it's vertically stretched graph.